Right. What I'd like to do now is briefly talk a little bit about some of the ISIS runtime parameters that you have control over when you build applications and want to install them. In a lot of systems like ISIS, there are piles of configuration parameters sitting around, and you never touch them. To some degree, you can do that with ISIS too. You can ignore these parameters. But very often, you're going to want to take an ISIS application and move it into a setting which might not be the identical setting to where you did the development. For example, I do a lot of my development on a Windows desktop, but I often end up writing programs that are going to run on a Linux system with Mono. And as you make these changes, sometimes you have to warn ISIS about the setup of the environment that you're going to be running in. So I just want to show you what the key parameters you have control over are for those purposes. This won't take us very long, and there really aren't that many you can change. So the parameters we're going to be looking at fall into three categories. One of them involve how the system will start up. And the issue here is the following. When an ISIS program is launched, there are sort of two cases. One is that this is the first launch of an ISIS program that you've ever done or that you've done today. And the other is ISIS is already running and you're launching the 12th member who's going to join a group. ISIS has to find those other members and integrate itself with them, join that group. So I have to show you how that works, because otherwise you might not be able to guarantee that ISIS will find them. It has to have a way to figure out where they're running. Then there are some parameters that determine how ISIS sends messages. And oddly enough, people seem to be eager to try to change these. It's not such a good idea. I will show you what they are, but I wouldn't rush to change those parameters. And then finally, I want to tell you a little bit about some of the timeout parameters that control flow control and when failures are detected. And that's really it. So the startup parameters are the place to begin, and these relate to how ISIS is launched and finds other instances of ISIS running elsewhere. So the ISIS system launches when you've linked your program to the library and you call the ISIS system.start method. And this method causes the library to initialize itself, and at that point it figures out the IP address of the host on which you're running. Now, modern computers often have multiple IP addresses, so ISIS needed a way to decide which one to use as the main IP address for your computer. The normal default rule is it uses the last of the IPv4 addresses it finds for your computer by scanning the network interface cards that are local. All right, this is usually also what localhost would have mapped to, but I do want you to be aware of which one it is, because many people don't even realize that their computers could have multiple IP addresses or what those would be. Now, then the system scans what are called the environment variables, and you can set those. So, for example, anytime you're about to launch a program on Linux in Bash, you can call an export command in Bash and say export parameter equals value. Similarly, in Windows, you can say set parameter equals values right before you launch a program. And when you do that, that parameter that you've set a value to becomes part of what's called the environment. And ISIS scans the environment looking for environment variables that have values that it's worried about. And so if you modify these environment variables by giving them values, you can control the behavior of the system. You can also do that at runtime in your code, by the way. You can call setenv if you want to, or environment.set. I don't recommend code-based changes, and I certainly don't recommend editing the ISIS startup file. The smart way to do this is to write little launch scripts that just set the parameter value and then run the program, and then run that script to launch your program. Now, once the system start is running, what ISIS does is to decide which network interfaces it should use. So a given computer typically is interfaced to the network by what are called network interface cards, and each one of those corresponds to a network interface internal to the operating system, and ISIS can look through that list of interfaces, one for each card. Your Ethernet, you're connected to maybe 2 ethers, it'll have 2 such cards. You might be using InfiniBand or something else you've never heard of, and then it'll be a card for InfiniBand. Right? It scans through those. You can control which network interfaces ISIS will use. you would think, well, I should want it to use all of them, and that's what it will do by default. But it turns out that on many clusters that universities or other organizations run, there's actually an administration network that you're not supposed to use. Very often it's the first network card, and ISIS can skip the first network card if you wanted to. And then there's a production network, and you're supposed to use that. And you can tell ISIS which network card to use by just looking at the list of network cards that are on your computer. There's a command for doing that, or your systems administrator will tell you. And then you can specify through the ISIS network interfaces environment variable which ones you would like it to use. For example, you could say ISIS network interfaces equals ETH0, and if that is a valid Ethernet interface card, ISIS will only connect to that card. Now, once it's done that, the job of your application is to connect to the existing system if it's running and otherwise relaunch it. And for that, we have to find the membership oracle. So what ISIS is going to do is to look for a network oracle, and if it can't find the oracle, then if it's allowed to, it will restart the oracle on this machine that you're launching on. If it's not allowed to, it'll fail at that point and say, I can't do it. All right. Next, there's some logging features. When ISIS starts up, by default, it prints out all sorts of stuff that can be helpful for debugging the system and understanding why things went wrong. And it creates a log file for that. And you can inhibit this if you want by setting ISIS mute to true. You can also direct the logging output to different places. By default, it just prints them on the console. If you don't want that, you can force it to print, but print to the debug output. And you can actually control where the log file is placed as well. If you wanted to put your own application messages into the ISIS log file, you could do that, by the way, by calling ISISsystem.write or ISISsystem.writeLine. .write writes, but it doesn't put new lines, and .writeLine puts a line and then puts a new line at the end of it. And the output goes wherever the log goes. And the log is captured and also stored on disk. Okay? For speed, you can actually tell ISIS to skip checking for where the oracle is out there. And if you do this, you should be a little careful because there can only be one initial startup of the oracle. Okay, so here I've got, there can be only one Highlander, right? That was the deal. So if you're going to use this feature, here's how you do it. You would have to know that you were in the process of launching the first program that will use ISIS, and it should skip looking for the oracle and just start the oracle. And you do that by calling ISISsystem.start with an argument. The argument is just a Boolean true. And in that case, ISIS immediately starts the oracle. No delay will occur. It'll just take milliseconds. Then your other programs, when you launch them, you can't use that same feature, or else they'll all end up as separate partitioned versions of ISIS. So for those, you launch in the normal way, and then they find and join this initial oracle that you started. Okay, so you do this only in the first version, but it would be very fast if you did that. Something to be aware of if you start to play with ISIS on a large scale is you can kind of overwhelm the system. So here's what's happening. Suppose that this red program is starting up and it's trying to find the oracle. So it says it does actually a network broadcast unless you tell it where the oracle is located, which you can do by specifying a value for something called the ISIS hosts list. But if you don't specify that and you let ISIS use multicast, then which is its default, it sends out a broadcast and says hello, and one of those reaches the oracle, and the oracle responds welcome. But what happens if you start a lot at once is that you can get a situation where large numbers of these requests pound on that oracle simultaneously, causing it to be overwhelmed and to drop requests. And that will slow your startup up. And you might even have some members who don't manage to start up at all because they can just keep having the bad luck to have their request dropped. So we have a notion in ISIS of a master worker startup that you might consider using if you plan to work with large numbers of copies. I would say more than 25. I would switch to this. It'll be a lot faster even at 25. On the other hand, if you're just going to be running 4 or 5 copies to demonstrate a system to your professor or your boss, you wouldn't need to worry about this. So with large numbers of instances running, what you do is you launch a master program first, and it writes down its address, and we have some recommended ways of writing down the address, and then the workers read the address of the master in one of those different ways, and at that point they join as workers. And the join as workers scheme is a little bit of code. I've shown it here, and you can see it's not trivial. It's about a page of code that you have to write, in which this is showing the master right this minute. So the master runs as the master, and you can see he does a start in the normal way, then forms a list, and then the workers, as they get launched, cause upcalls to this routine that's defined in the ISIS register as master method handler. And in this particular case, it keeps adding the workers to a list, and the list accumulates until it's long enough that it has the right number of workers for the application that we're building here. This particular one has this notion that you're fully staffed when you reach goal workers. I don't know what goal is, maybe 25 or 50. And at that point, it batch starts the entire set of workers, which then can set up their groups. Then they say that their setup is done, and at that point this guy does a multi-join, adding the whole batch of workers to the groups. You can see we needed all of those steps because first they all needed to get past the ISIS system start. So that was the first step where you accumulate your workers. But then once you're past system start, they still had to set up their groups and attach their handlers to the group before they could be joined into the group. And so we had to get this sequencing, which is why this code is a teeny bit complicated. And then the last thing that this program does here is it sits in something called ISIS_system.waitForever. One of the issues we have with ISIS, and we talked about this separately, is that once the program is launched, it shuts down automatically if the main thread terminates. But what if this program is supposed to just sit there waiting for events? Well, in that case, what you do is you actually call ISIS_system.waitForever. It never really returns, although I put an ISIS system shutdown call after that. That's not really necessary here. And then run as worker is another page or so of code. And you can see that the worker, instead of calling ISIS_system.start, the worker calls ISIS_system.run as worker. So that's a big difference. And it has to tell run as worker where the master is by passing in a string, which is typically what we do is the master writes out his address and then the workers read it in, and that becomes this argument which they pass to run as worker, at which point they call ISIS_system.start. And then after that, they have to do some setup, which is not shown here. And then after that, they call worker setup done. And once they've done the setup, they are like other members of any group. And in this particular case, they check to make sure that the first view has been received for each group, and then they sit and wait forever. Okay. So this pattern is one that you would just copy if you wanted to use the master worker pattern. And you get something like this. A worker first talks to the master who wants to accumulate workers. Then eventually you reach the goal, at which point the master batch starts the workers. Then the master can set up groups, and it also has to wait for the workers to set up their groups. And then when the worker setup done is called, the master can batch join them, which is done with this multi-join, at which point the master does a wait forever. And now the system is in the same state as if they had all just sort of joined willy-nilly. So that works quite well. This check to see if the groups have their first view avoids trying to use a group before the state transfer is finished. This isn't really necessary in the sense that ISIS protects against mistakes, but it'll avoid timing problems where your application starts to run some replicated code, but some of the members haven't finished joining. And because they haven't finished joining, there could be long timing delays that would disrupt the measurements you might be doing for an experiment, for example. So it works better if you wait until you're sure the groups are all in a reasonably stable state before you start using them. Okay, so this helps because instead of all those broadcasts, just one message is sent to the master, so it gets less load. And because it adds all of the workers at once, it turns out that the system is very efficient about changing the membership in this case, and so only one message ends up getting sent that initializes all of those members, and that's very fast. Saves time and it avoids overload. So let me talk about the messaging parameters next. ISIS has a choice. Does ISIS have permission to use broadcast or not and multicast or not? So you can control that. There's a feature called ISIS unicast only, and when you use this feature, ISIS will not use multicast. Normally we use broadcast and multicast because they're a very efficient way to send a message from one source to many receivers. However, and ISIS will broadcast in that case to find the oracle. But you can disable that by setting ISIS unicast only to true. And if you do that, then you have to tell ISIS where the host that's running the oracle is located, but ISIS will connect to it with a point-to-point protocol. So here I've illustrated that. On the left, we've got some multicasts, and you can see one send, many receive. On the right, you can see trees of unicast, and that's the kind of inefficiency that arises if you tell ISIS it's not allowed to use multicast. So why would you ever do that? Well, it turns out that on some platforms, some cloud platforms, they don't like people using multicast, and there may be an administrative rule. Azure imposes such a rule, and so does Amazon EC2. So on those platforms, you have no choice. You have to tell ISIS to use unicast only. If it tried to use multicast, it would get 100% loss rates, because those systems block multicast. And so in those situations only you switch over, but you will have a performance hit, which is illustrated on this right-hand side, as you can see a message being relayed through a tree in order to get to its real destinations, maybe 2 or 3 hops. ISIS hosts is just a list of places where the oracle can be found. And so typically it'll be a list of string addresses, or it might be a list of numerical IP addresses. And processes running on other machines can join the system, but they won't be allowed to restart from scratch. Restarting from scratch involves relaunching the oracle, and that can only be done on the ISIS hosts if you give a value for ISIS hosts. Numerical versions of these IP addresses work best. It turns out that there's a bug on the Linux Mono platform in which if I try to map too many string addresses to IP addresses, Mono malfunctions and sometimes can hang. If you give me IP addresses as numerical IP addresses, the Mono method that handles that doesn't ever hang, and this overload never occurs. So my recommendation is that the values you put into ISIS hosts, that you translate them to IP addresses first, and then give me the addresses. However, if you give me strings, I will translate the strings. Just be aware that in that situation, if several such translations occur concurrently on different machines, Mono has been observed to freeze up. That's unfortunate, but that's life. You can also tell ISIS which internet port numbers to use. You set one, it's called the ISIS _ port for point-to-point, P2P traffic, and it's small p. And then it automatically has a second port that it uses for acknowledgments, which is always going to be set to P+1, so you don't have to tell me what that is. And at that point, you have to make sure that your firewalls will allow traffic on those ports, but ISIS will use them. There's a default value that's built into the system. It's something like 7593. You can look it up. But you should change it to a value that makes sense to you if you're on a platform where that's important. Be careful to say yes, it's okay to deliver and unblock those ports, because otherwise the members won't be able to talk to each other. You can control the maximum number of multicast addresses that ISIS is allowed to use. So in this case, you can set the maximum number, and you can also set the ISIS range. We call it ISIS multicast range, low to high, and that will determine the range of IP addresses used for IP multicast if you're allowing ISIS to use IP multicast. And this avoids us overloading the network routers in your setting. There's also a way to control the time to live, the TTL value for packets, which determines how many times they can be relayed and routed by routers, how many hops these packets can take until they reach their destination. If the TTL is 0 or 1, what that means is the packets will be sent in the local area network only. If you set it to a number like 5 or 20 or something, then they can reach destinations as that many hops away. Routers decrement the TTL, but switches don't. So if you start to play with these values, you really have to talk to your network administrator and understand what the correct number to use is. By default, ISIS is using a TTL of 1, I believe. There's a maximum message length parameter. You can change it, but I don't really recommend that you do that. What ISIS typically does, if you don't specify a value, is to read it off the network interface cards and use the smallest value that it finds on any of the network interface cards. But then what happens is that if an ISIS message is bigger than that maximum, it will automatically be fragmented into parts and then reconstructed later. So let me tell you about a couple of other limits. You don't change them much, so I'll just mention them. There's a default timeout which determines when failures will be sensed. The normal value for this is 45 seconds, which is really very slow. But you can modify it by setting a different value of the ISIS default timeout. Don't try to set it to be smaller than 2 seconds, though. If you want to detect failures quickly, the better way to do it is to build a failure detection method of your own and then call isis.processFailed, specifying the ISIS address of the process that failed when you believe that somebody has failed. You can do that as quickly and as efficiently as you're able to sense the failure. If you set the default timeout too small, small scheduling delays may be enough to cause delays in ISIS that would trigger failure detection, and then you'll have people who are dropped out of groups for no good reason. You will see in those situations an indication. So if you have a process which is thrown out of a group because it wasn't responsive, the process will throw an exception that we call a poisoned exception. The way to think of it is that the rest of the system moved on and considers that this guy has crashed. But if it actually manages to talk to that crashed process, the message it sends says, hey, I'm really sorry, but we've abandoned you. That's a poison pill message. And then the recipient says, hey, I've been poisoned. So if you're getting those kinds of errors, it means that the process that threw that exception wasn't responsive to incoming ISIS messages for 45 seconds or 90 seconds, some very long period of time. Why could that happen? And usually the answer is either you wrote code that caused the entire program to block, to freeze up for that long, or you're on a platform like EC2, it got overloaded and the program just was unresponsive because it was thrashing. So those are usually situations where you want to look at the machine where you got the poison exception and ask, why was it running so slowly? And you'll often find a memory leak or some kind of resource overload, which is causing the program to literally freeze up for 90 seconds. And that's why ISIS thinks, well, it's time to move on and not wait. Okay? And in that situation, you probably have a bug to fix. So, as I said, if you want fast failure detection, there are several things you can do. You can detect the failures yourself. The other thing you can do is when your members of a group exit the system, make sure that you call ISIS shutdown first, because when you call ISIS shutdown, the exiting member notifies the others that it's exiting from ISIS, and that triggers instant failure detection in those other members. If you exit without calling shutdown, then they aren't notified and 45 seconds will elapse before anybody notices. So if you want to impress people with the fast failure response of your application, it's important that ISIS knows when the applications have failed and also that it knows when they've gracefully terminated. ISIS shutdown will do that for you. On EC2, we recommend you have to use unicast only. And keep in mind that EC2 sets up virtual clusters. So if you use this, it turns out that the virtual clusters have a very nice numbering method. And in the master worker startup mode, you can take advantage of that by creating a new address which has the IP address of your virtual cluster .0 as the master's node. Run the master on that node, and then use 0 as its process ID in the ISIS address. And this will work beautifully and gives you a very simple way to figure out who the master is on EC2 in master worker mode. And there's a write-up about that in the ISIS manual, by the way. So how do you debug with ISIS? It's quite hard, it turns out. You can attach a Visual Studio debugger or other debuggers to ISIS, but you're going to see a great number of threads that ISIS itself created. Your application code, you can definitely get to it. You can look at variables. But my code is complicated, and there'll be all these threads running, and that may be a little confusing. So I don't really recommend single-stepping the way you do with a single program instance. Generally, what I find most effective is to print things into the log and then stare at the printout. I know this seems very backward, but it's what works best for almost everybody. If you like, you can ask ISIS to print the system state or its runtime statistics, and you can see how many messages have been sent. Sometimes that's helpful when you're debugging a performance or a networking issue. ISIS is multi-threaded. Be careful to write multi-thread safe code, especially if you use threads. And be careful not to block for long periods of time in your ISIS threads. Keep in mind that ISIS does have a lot of threads, but you won't see them generally unless you try to run the debugger. But this is one reason that freezing an ISIS application and single-stepping it goes terribly wrong. You're not just freezing your threaded code, you're freezing my threaded code. And that means this application is acting very sick at that point. And the other ISIS members of the group are going to think it's dead in no time at all. Post questions on Codeplex if you're not sure what's going on the isis2.codeplex.com page, and I'll answer them. So I'm going to stop with that, and we'll take up a different question in the next module. Okay, so that's that. And I think you and I are going to break for lunch here because I have to join that faculty lunch meeting. And I'll be back by about 1:15 at the latest. 1:15, okay. And we can just pick up then. And then I'll be good until there's this brief meeting in the afternoon again. Meanwhile, if you get here before me, you could try merging the two Panopto modules that we had before.
That's fine. Yeah, I think I have to be done around 2 today.
That's okay, because as I said, we're never going to get through all of this in one shot.
Yeah.
Exactly. We'll just do one at a time. I've only got about 8 of them, but it is 2 days of work. That's okay. Just track your hours and best. Should I leave this unlocked so you can get in without me? Your stuff is safe here. Nobody's going to steal cameras.
Yeah, right. It's fine.
Right. So we'll just pull the door closed, and if you get back before me, you can stitch together that second.
Okay. So what time do you think I'll be back?
I believe I'll be back by 1:15.
1:15. Okay.
1:30 at the very latest. But I'm going to try to be back by 1. Okay. Next thing